Hello friends, today I will be discussing on important test which is called as Chi-Sqaure test. So Chi-Sqaure test, whenever you are doing quantitative research and you have got non-parametric distribution of data or Chi-Sqaure distribution of data, at that time you are using Chi-Sqaure test, or whenever your data is collected in the basis of frequency or on the basis of categorical observation, or whenever it is calculated in terms of nominal scale, then you are using chi-square test. Basically, whenever it is a frequency based data, then you are using chi-square test. So in this presentation we will be understanding what is chi-square test, and also we will solve different problems based on different types of chi-square tests, and then we will try to understand it in better way. So what is the basic background of chi-square test? So chi-square test is a statistical test used to determine whether there is a relationship between two categorical variables. So categorical data set, if it is there, suppose you are saying that gender, and then you are saying that uh, food choice. Food choice. Suppose someone has got food choice for sweet food and someone has got food choice for sour food. Both the data you will calculate, you will collect data on the basis of frequency. So you will have number of peoples in terms of frequency, and then you will have got preferences for food. So whenever the categorical data is there and you just want to study that if the food choice is anyhow related to the gender, then it is a case of chi-square test. The test is valid when the test statistics is chi-square distributed under the null hypothesis. So the test is valid when the test statistic is chi-square distributed under the null hypothesis. Specifically, Pearson chi-square test and variance thereof. Specifically, Carl Pearson has developed this chi-square test, and when the distribution of the data will be chi-square distributed, so that is one specific type of chi-square distribution. So in that particular case you are using chi-square test. So one assumption is the data should be in categorical scale or nominal scale. In that type of cases, or it is in frequency, then you are doing chi-square test, and then the data should be chi-square distributed. In the 19th century, statistical analysis methods were mainly applied in biological data analysis, and it was customary for researchers to assume that observation followed a normal distribution. We were assuming that every distribution was normal, but Carl Pearson was against it. He was saying that no, all the distributions are not normally distributed, and in case of where the normal distribution is not there, then you have to use different other types of tests based which are non-parametric in nature, and then this chi-square test is one of that tests which comes under non-parametric test. So when the data is not normally distributed, you are performing chi-square tests. The chi-square test is an important test amongst the several tests of significance developed by statisticians. It is one significant test. Many a times you just go on seeing the literature, seeing the research studies. Many studies are based on chi-square, because many a times you are calculating the frequencies, you are having data in categorical scale, and many times suppose you are using a rating scale, how many preferences a particular person is giving to a particular category. Suppose a particular those who are in support of a particular uh, idea, how many are in favor, how many are in not favor, how many are indifferent. So in that particular type of case also you are using chi-square test. So it was developed by Carl Pearson in 1900. The chi-square test is a non-parametric test, I already told you, and on any assumption of the distribution of any variable. So any type of non-normal distribution, you are using chi-square test. The statistical test follows a specific distribution known as chi-square distribution. In general, the test used to measure the differences between what is observed and what is expected. So in general, you will see that how the chi-square will function. In general, it tends to study what is expected and what is there in the field or what is being observed, and if there is difference between the expected and observed value, then you are saying that the value is significant, there is a relationship, there is association, or you are saying that the particular observed value is not fit to the normal expected frequencies. So in these cases you are using chi-square test. Anytime, whenever you are using chi-square test, this is the particular thing you are doing. You have to find out a frequency which is observed and the number of expected frequency what it is there, and then you try to compare, and then if the figures are quite different, then you are saying that the hypothesis is cannot be accepted and the alternative hypothesis is true. So in that way it used to work. Now this test is based on frequencies, whereas in theoretical distribution the test is based on mean and standard deviation. I told you it is totally based on frequency. Whenever you are calculating data on the basis of frequency, you will be using chi-square test. The other distribution can be used for testing the significance of difference between a single expected value and observed proportion. However, this test can be used for testing differences between the entire set of the expected and observed frequency. That also I have told, that it tries to check what is expected and what is observed in the field, and then we try to compare and give you that if the results are significant or not significant. In chi-square distribution, you will also study what is the degrees of freedom for a chi-square test. This test is applied for testing hypothesis but is not useful for estimation. You are not able to predict anything, or you are not able to estimate anything, but you are just saying that if the association is there or if any relationship is there. So that much it is trying to do. Now what are different types of chi-square test? Basically it can be divided into two different types. First one is chi-square goodness of the fit test, and the second one is chi-square test of independence. Let me try to explain these two types. The first tries to see that what is expected outcome, according to the theory. Sometimes it may be a normal distribution, sometimes it may be the outcomes should be equally distributed across different categories, sometimes normal distribution should be there, sometimes it is mathematically what should be the outcome according to the probability theory, what should be the outcome. So that is the expected one, but what is actually happening in the field, that you try to compare, and then you are saying that it is good to that particular expected outcome, or it is not fitting to that particular criteria. So that cases, suppose you are saying that a particular person has a choice for suppose in a rating scale a particular party is there and people are asked, do you support, or suppose one motion is there, suppose one law is there, and then you are asking the people to vote for that particular law in support or against. Now expected outcome is that it may be normally distributed, but in the field if you collect the data and you are finding that it is not normally distributed, then by doing chi-square test, if you are seeing that it is not normally distributed, so you are saying it is not good to fit that particular expected outcome. So in that particular situation you are using this. Similarly, suppose head and tails, you are tossing the coin and you are saying that according to the probability theory 50% chances are there for head, 50% chances are for tail. But if you are doing with a coin, and then how many times head is coming, how many times tail is coming, suppose in 20 trials, and then you are trying to compare with the normal probability outcome, expected outcome, and if it is fitting to that particular criteria, you are saying that that particular outcome is as per expectation. So this type of cases are called as chi-square goodness of fit test. Now chi-square test of independence, this test determines if two categorical variables are related or independent to each other. That just now I told you, suppose you are thinking that if gender has any role to play with the food choice. So you collect the gender boys and girls, and then you ask them if their preference for food, they like sweet food or they like uh, sour food, and then you try to take out that particular cases, and then you try to compare that what is the uh, number, means you are using contingency table, you use contingency table, and according to contingency table what should be the outcome and what is actually happening in the field, how many choices based on different gender particular person is talking about that they are liking sweet food or they are liking sour food, and then you are making a contingency table and doing the chi-square test, and you are able to say that yes, that there is a relationship between gender and that particular food choice, or it may be, or it is not there. So in that type of cases, or suppose you are saying that is there any relationship between height of the person and his intelligence. So you collect height of the person in terms of average height, because it should be in categorical variable. So average height, make one category that this much centimeter will be up to average, and this much centimeter will be in the short heighted, and this much centimeter height will be in tall heighted, or similarly in the intelligence make three category: high, average and low, and then you make a contingency table and just try to see, means you collect data in frequency and then you try to write that particular in terms of a contingency table, and as per contingency table calculation you put the expected outcome, and then you just try to see if the chi-square value is significant or not. So these two type of situation are occurring. One is goodness of fit test and other is test of independence. Both the tests used to do whenever you are doing chi-square test. These both are the main type of test in chi-square test. Now let us see chi-square test of goodness of fit test. So let us see that one. Okay, so this is one question related to goodness of fit. In a poll survey questions, the observed choices are as given below. One particular question was there in a poll survey, and the observed frequencies are as this. How many were supporting that particular question? Particular government has worked towards the progress of the poor people, support this. Now as it is saying follow the principle of equal distribution, it is saying that it should follow the principle of equal distribution. So the expected outcome should be in terms of this 48, total 48 responses are there. So if it is equal, this situation is there for equal distribution, it will be divided into three category of 16 each in every category. So this is the formula for chi-square. You can see chi-square formula. So you have got these values. You just try to see if you will do this calculation for FO minus FE. So for first column for this yes no condition, the FO minus FE is 8. So and then you square it will become 64, and then you divide it by FE. So FE is expected is 16. So 64 divided by 16 is 4. Similarly for no condition, the difference is 4, and then you square it, then it becomes 16, and 16 divided by FE is expected is 16, so it becomes 1. And the same thing will happen with the third category also, same values. So difference is -4, or you square it and then you divide it by 16, so we will get 1. So chi-square value is 6. 4 plus 1 plus 1, 6. Now if you see the degrees of freedom formula, the formula for degrees of freedom is rho minus 1 and multiplied by column minus 1, column minus 1. So here rows are 2, this is one row and this is other row, so 2 minus 1 1, and column is 3 minus 1 2. So 1 into 2 2, 2 is the degrees of freedom. Other formula it is given as 3 category minus 1, 3 categories of responses are there, minus 1 2, but this is the general formula, row minus 1 minus into column minus. So if you see the table value at 0.05 for 2 degrees of freedom, the table value is 5.991. So the obtained value is 6, so it is more than the table value, so we have to reject the null hypothesis, and you can say that the observed outcome is significant. So in this way you used to apply chi-square test in case of goodness of fit test. So let us take one more example. In an attitude scale item, the outcomes are as given below. So FO is given, and this is FO. You can see this FO is there, 1626. So here you have to follow the principle of normal distribution. So according to normal distribution, it should be 68%, around 68% cases should be in the average level or not applicable level. So we are keeping 28.6 number of cases. Total is I think 42. 68% of 42 is 28.6 is the number of cases expected according to normal distribution, and similarly remaining cases will be distributed in yes and no. So this is as per normal probability distribution. This is expected. This is the expected outcome. So here expected outcome is according to normal distribution. Now you will use this chi-square formula, FO minus FE square divided by FE. So try to calculate the, for yes it is 16 minus 6.7, 16 minus 6.7 square divided by expected 6.7. You will get 12.90. Similarly for not applicable it is 2.59, and then for no it is 0.07. So you add these three because chi-square is summation is used here. So if you add this you will get 15.56. This is the calculated value. Now if you see the degrees of freedom, again you will use the same formula, row minus 1 column minus 1. So row minus 1 is a 2 minus 1 1, and column minus 1 3 minus 1 2. So 2 is the degrees of freedom, and if you see the table value, these are the table value at some specific levels of significance. At 0.05 level of significance it should be 5.991. 0.01 level of significance it should be 9.210, and 0.001 level of significance for 2 degrees of freedom it should be 13.816. So but obtained value is quite higher, 15.56. So it is quite higher, and you have to reject the null hypothesis. So you can say that the outcome is significant, and you have to consider the result. It is not according to the normal distribution. Now we have already seen the case of goodness to fit. Now the second type is test of independence. So in addition to testing the agreement between observed frequency and those expected from some hypothesis, that is equal probability and normal probability, chi-square may also be applied to test the relationship between variables, if they are associated, if they are related. In this we test whether two variables are dependent, associated, or independent to each other. So in the following table is known as contingency table. So here you try to make contingency table. This is one type of contingency table, you can see. So you have got some type of matrix arrangement, and in that matrix arrangement you try to put the values, what is the actual observed frequencies, and then accordingly you calculate the expected frequency, and then you perform chi-square test. So contingency table is a double entry or two-way table in which the possession by a group of varying degree of the characteristics is represented. The same person, for example, may be classified as on the basis of sex, that it is boys and girls. As I told you, if gender has got preferences for food choices, so gender can be classified into two categories, boys and girls, male or female. And the other you can say about, suppose the eye color, suppose the color of eye is anyhow related to gender, so the other category, so here in this category it can be male and female, and in this category you can arrange the eye color. So like this you can arrange the snacks, and suppose here it is given snacks and soda. So if some relationship is there in between soda choice and snacks choice, so in this way you are arranging the contingency table. So for the test of independence, the assumptions will be identify the variable and the level of measurement. You have to categorize, like gender, you can categorize it into a male and female. Similarly, the data obtained should be from a random sample. It should be from a random sample. The expected frequency for each category must be 5 or more. If it is less than 5, then you have to go for Yates correction. I am not discussing that one. Yates correction you can do. You have to subtract 0.5 from each of the values, and then you have to make the square and do the things. But if it is 5 or more than 5, it is not required. Now the hypothesis are the two variables are independent. There is no relationship, of course, like that. You are saying that gender has got relationship with the eye color. So the null hypothesis, there will be no relationship. And the alternative, the two variables are dependent. There is relationship between the two variables. If the null hypothesis is rejected, then the alternative hypothesis will be correct. So as I already told, what is contingency table? Let us try to understand again. So contingency table, when you want to perform a chi-square test of independence, the best way to organize your data is a type of frequency distribution table called as contingency table. A contingency table, also known as cross tabulation, it is just type of matrix arrangement. It is one type of matrix arrangement. Cross tabs are being made and shows the number of observation in each combination of groups. So suppose I told you that gender is one variable where male and female will be shown in the column axis, then eye color will be in the row. So brown or black or blue, three eye colors category can be shown in the rows, and the gender can be shown in the columns. Like this you can make it your cross tabulation. Like this you can make. So suppose here boys and girls will be there numbers, and here eye color will be there blue, then black, and then brown, like that. So you can put the number of frequencies here. So the boys who are having blue eyes, you will put the number here, suppose 30. The boys having black eyes, you can put the values here, 25. The boys having brown eyes, you can put the values here. So like this is one contingency table. Using this contingency table only, you will calculate the chi-square. Similarly, for the girls also, you can put the values. For girls, suppose blue eyes, girls are 35, and then black eyes, girls are 40. Then brown eyes girls are like 36. So like this you will arrange, then you will go for chi-square value. That you will understand once you will take one example. So a contingency table is also known as cross tabulation or cross tab. It also usually includes row and column. So these are columns, one category is there, and in rows other category is there, eye color, and in the columns the gender is there. So this is contingency table. Now the degrees of freedom, as I already told, degrees of freedom is row minus 1, column minus 1. So in the contingency table which I just made, the number of columns were 2 and number of rows were 3. So number of column is 2, that is 2 minus 1, 1, and row is 3, so 3 minus 1 is 2, so 2 into 1. So degrees of freedom for this particular example will be 2. So this is the way you calculate degrees of freedom. So this is the arrangement. You can see this is one contingency table. You can easily see this is one contingency table. Column, 3 columns are there and 2 rows are there. So degrees of freedom is here. Again it is 2, because row minus 1 is 2 minus 1, 1, column minus 1, 3 minus 1, 2. So it will be 2 in this particular case. So in that way you are calculating degrees of freedom. Now let us take one example for this contingency table case where you want to see the association or relationship. Suppose you want to test chi-square test the agreement between observed result and those expected on some hypothesis. Suppose we wish to investigate the relationship between traits or attributes which can be classified into two or more categories. The same person, for example, may be classified as handedness. He may be left-handed, ambidextrous, or right-handed. So a person may be categorized in terms of his uh, hand use, in which way which hand is more powerful, he is using more. He may be left-handed, he may be right-handed, he may be ambidextrous, means he can use both the hands simultaneously. Similarly, eyedness, a person can be left-eyed person, right-eyed person, and he can be ambicular. Ambicular also he can be, means having both, using both the eyes in the same capacity. So for this particular, if you want to check if that handedness has some relationship with eyedness, then here also you can perform the chi-square test. You have to construct a contingency table and then you can perform the chi-square test. So this is the contingency table, what question I was talking about. Here in these columns you have got eyedness categories, left-eyed, ambicular, and right-eyed, and then here in the rows the handedness is there, left-handed, right-handed, ambidextrous. So suppose the person, those who are left-eyed and left-handed, is 34. So the figure which is there in the outside the bracket parenthesis is the observed figure, 34, 62, 28. So right-eyed person, those who are left-handed, are 28. Right-handed person, those who are right-handed, are 52. So in that way, the figures outside the parenthesis are the observed frequencies. Now to get the, and then the total is there. If you add these three, you will get 124. If you add 27 plus 28 plus 20, you will get 75. 57 plus 105 plus 52 is 240. Similarly, here also if you will add, you will get 180. This is 195. 28 plus 20 plus 52 is 100. Now whatever expected frequency, for calculating expected frequencies, you have to use this particular formula. What you will do, suppose you have to find out this particular value for left-eyed and left-handed expected frequency. So what you will do, this you will multiply this row total multiplied by the column total divided by the total. So 118 multiplied by 124 divided by 413 will give you the value of this expected left-eyed left-handed person. So just you see this value, this particular 118 into 124 into 413, 35.4. You have got 35.4. Now left-eyed person, those who are ambidextrous, what you will do? The column total is 75, row total is 118. So you multiply 75 into 118, 75 into 118 divided by 413. This particular case you will get 21.4. Suppose you want to do for this particular value, the person who is ambicular and ambidextrous, the column total is 75, the row total is 195, or I am saying in the other way, the row total is 75 and the column total is 195. So 195 into 75, this particular thing, 195 into 75 divided by total 35.4. Similarly, suppose we want to get this one, last value, expected frequency, right-eyed person having right-handed capacity. So what you will do, this row total is 214, column total is 100, this one 214 into 100 divided by 413, you will get 51.8. So in this way you find out expected frequencies, row total into column total divided by overall total. Now you have got FO are already there, FE you have found out, FE you have calculated. Now you will use this chi-square formula. So you know the chi-square formula is FO minus FE. So here 35.4 minus 34 is or FO minus FE will do this. So 34 minus 35.4, 1.4 square divided by FE. FE is 35.4. So you got this value. Similarly, for this particular box, you can see that it is 62 minus 58.5, 3.5 divided by 58.5 square into, and then divide. So FO minus FE divided FO minus FE square divided by FE you are doing for each of these boxes, and it has been shown here. Suppose for this particular box it is 57 minus 61.1, this particular value minus 4.1 square divided by 61.1, so you will got 0.275. So once you got this all values 0.055, 1.465, 0.275, 0.209, 1.547, 0.158, 0.133, 0.178, 0.001, then you, for finding out the chi-square value, will add these all 1, 2, 3, 4, 5, 6, 7, 8, 9 values you add, and the calculated value is chi-square value is 4.02. Now once you compare with the table value, here degrees of freedom will be 4. How? Column is 3 and row is 3. So 3 minus 1 2 and 2 minus 1 2 and 3 minus 1 2 for the rows also. So 2 2s are 4. For degrees of freedom of 4, you see that it is not significant at 0.057 because P lies between 0.30 and 0.50, which is not the level of significance, expected level of significance. So you can reject the null hypothesis, you can reject the hypothesis, you have to accept the hypothesis, and you will say that there is no relationship between idleness and the handedness. So in that way you will find out, use the contingency table to establish certain relationship, certain association. Now this is another question. The question says that all the 6th grade children in a public school system are given a standard achievement test in arithmetic. A sample of boys drawn at random from the 6th grade population showed 23 at above the national norm in the test and 17 below the national norm. So in a mathematics test, you see that how many students are above the national norm, 23, and 17 below the national norm. A random sample of 56 6th grade girls showed 22 at or above the national norm and 28 below. Are the boys really better than the girls in arithmetic? So total boys were 23 plus 17, it is 40, and girls is 50. So in 50, this is the distribution. If once you will see the table, you will better understand. So this is the table, you can see. So the table value says that boys below the national norm, what is expected national norm is there, below that whatever value it may be, 17 boys perform below the national norm and 23 boys perform above the national norm. Similarly for girls, out of 50 girls, 28 were below the national norm and 22 were above the national norm. So in this case, this is one other example. This case you are not finding out expected or this frequency, only you have to take care of the observed frequency. Whenever this type of situation, 2 by 2 situation is there, in that type of cases you use this chi-square formula. You denote this as A, B, C, D, and then you don't have to find out this multiplication of row into column divided by total. You just use this formula and into AD minus BC, AD, BC, and divided by all the addition, A plus B, C plus D, A plus C, and B plus D. All are there. These 4 will be in the denominator. So putting these values, you will get 90. AD is 17 into 22 is 374, and 28 into 23 it will be 644. So you get the values, chi-square values. This is one changed formula. You can use this one also to calculate the chi-square value. No need of calculating the the each expected frequency, it is not required. You will just use this formula and calculate the chi-square value. Whenever 2 cross 2 table is there, you can use this one. Whenever contingency table will be 2 cross 2, then you can use this one. So chi-square is 1.62, and the degrees of freedom will be of course 1, row minus 1, column minus 1, 2 minus 1, 2 minus 1, so it is 1. So if you compare this value with the table value, the p value is 0.20, which is not a standard level of significance. So chi-square is not significance. There is no evidence that the table entries really vary from the expectation. That is, there is a true sex difference in arithmetic. So there is no sex related differences, and because the figures are not significant, you say that the performance of the gender is as per the expectation, and there is no such sex related differences. So this was about chi-square test. Chi-square test used to calculate using these formulas. Two cases of chi-square is there. One is goodness of fit and the other one is test of independence. So for the goodness of it can be equal distribution, it can be according to the probability theory, according to the normal distribution. And for goodness in test of independence, you have to consider a contingency table. If it is, you can calculate the expected frequency and you can do the things as per the formula of chi-square FO minus FE summation FO minus FE square divided by FE, and then sum it and we get the chi-square value and see the table. If the contingency table is 2 by 2, we have got the other formula which I already told you, and the frequency of each of the cells should be more than 5. Otherwise, we have to use Yates correction. We have to subtract the values of the observed frequency by 0.5, and then you can calculate the chi-square values. So in that way you can solve chi-square value. It is very useful test. I hope you have understood this particular chi-square test. So if you like this particular video, kindly subscribe to the channel. Thank you. Keep learning, keep growing. All the best.